Okay, good evening, everyone. I'll start with today's class. Today we'll be doing AP and uh, we'll start with arithmetic progression this week. By next week, we'll complete geometric progression also. I'll mention the theory initially, and then you can apply it. I hope most of you would know it already. That an, or this is the nth term of an arithmetic progression. This can be written as first term plus n minus 1 d, where terms like a plus d, a plus 2d, and so on. These are terms of an AP, and this is written as a1, a2, a3, and so on. Okay, and there are a few uh, formulas for the sum of such a series. I'll not be proving them right now, but the sum of an AP can be written as Sn equal to, this is sum of n terms of an AP. It can be written as n upon 2
n upon
into,
2 bracket a plus n.
no, not a plus n, n 2n minus 1 t.
Sir, L means the last term only, na? This is only the last term.
1 second. Achha, a plus n, yeah, correct. Either it can be written as this, or it can be written as
Sir, we
n
can
by 2.
separate it as a one first term and a plus n minus 1d. It will be the last term. So
Sumit,
we
yeah,
can.
Sumit, I know you know this, but please don't interrupt while I'm explaining or mentioning it. You can, if you see any inaccuracy here, you can of course interrupt me. You can either write it as this, in terms of the first term, common difference, and the number of terms, or you can write it in terms of the number of terms, first term and last term. Okay. You can also write this is equal to n into m, where m is the middlemost term, where m is equal to the middlemost term. Also, you can notice over here that this is a quadratic equation in n. Sn is a quadratic in n. Sn or S0 is 0, S1 is equal to A. These are few stuff that you can keep in mind. Uh, you can note this down. This might be useful in solving the next few questions. Okay, so this is the theory of arithmetic progression. We'll not be doing basic questions. We'll straight go into doing uh, AMC 10, AMC 12 level questions. We'll also be doing a little bit of AIMA questions also. So where were we? We were on question number 15. Question 16 will be for each each of the positive integers k. Sk is the sequence of increasing terms of an arithmetic progression such that
Sir, what is
k
S?
I'll explain. I'll give an example after I've written down this, such that K is the common difference of such of the sequence SK. For example, S of 3. One second. One more point is K is the common difference of sequence SK, and first term is 1. Okay. So for example, S of 3 can be written as 1, 4, 7, 10, dot, dot, dot. So all of these sequences will start with 1, and their common difference will be whatever number is over here. So SK will be 1, then 1 plus K, 1 plus 2K, and so on. Now what you have to do is, how many of these sequences SK will contain 2024 in it? Try to solve this question. Sorry, yeah, over here this will be NM, not NM by 2. Is anyone having a doubt in this question? Then I'll explain or clarify.
So the first term always remains 1, right?
Always remember.
Okay.
What is the meaning of S? See, I am just denoting a sequence by SK. Is that what you're asking? Sumit, correct. Good.
So will you please look at it?
I'll wait for some time.
Sir, any
Pranshu, not correct. Try again.
sir, any bonus question today?
No bonus questions. I'll be just doing simple questions. If you get the answer, put it in the chat, and then I'll let you know if the answer is correct or wrong. I'll wait 1 more minute. After that, I'll explain this question.
Yes, I'm meeting chat again. So is there any other method of than finding the factors of
No, I'll be using that method only. Jivna, not correct. Pranshu, that is, those are not the only numbers. There is one more number, like 2023. K equal to 2023 is also valid. Shubhanyu, answer is not correct. Okay, so I'll start solving question 16. See, I can now define A of K comma N as the nth term of sequence SK. Is everyone fine with this? I start this question by noticing that there are sequences SK of increasing terms of an AP such that K is the common difference of the sequence. First term is 1. So our sequence is always like 1, 1 plus K, 1 plus 2K, and so on. Then I can define some quantity called AKN, where this is the nth term of our sequence SK. And since this is an nth term of an arithmetic progression, I can write that A K comma N is equal to 1 plus N minus 1 K, where this is the first term. This is common difference. And this is our simply the number of terms minus 1 from our first equation that I had written over here. Okay. Then you have to equate this to 2024, which is the present year that's going on. Then we'll say that this implies n minus 1 times k equal to 2024, 2023. Now n minus 1 is an integer.
So I don't understand why we do 2023.
Because I subtract 1 from both sides. So this 1 plus, so what do we want? We want a term of some sequence to be equal to 2024. Correct. That is what. How many of these sequences SK will contain 2024 in it? So that means one of the terms has to be equal to 2024. Then I subtract 1 from both sides. I get the product of these two quantities is 2023. Since n minus 1 is an integer and k is also an integer, k is the factors of 2023. Now all you have to do is factorize 2023. 2023 is divisible by 7. So you get 7 times 289 if you divide it properly. 289 is 17 square. So this becomes 17 square. Now, just keeping 7 and 17 square as it is, you can write the factors as 1, 7, 17. Then next will be 7 times 17, 7 times 17 square, and 17 square separately also. In general, if you have powers as 1 and 2, your number of factors will be 1 plus 1 and 2 plus 1. Okay, you just take the powers, add 1 to it and multiply them. This we will discuss in more detail when we do some more permutation combination questions or number theory related questions. But for now, these are your 6 distinct factors that you'll get. So K can be all of these and you get number of K will be 6. Is this clear to everyone? You don't need to take screenshots of this. I'll send a link in the chat. Everyone can make use of that to access the previous notes also and the future notes also of this class. Try another question and try to get the answer to this in one shot. Question 17. What is the greatest number of terms of an AP with consecutive integers and sum of such an AP being 45. Okay, so you have two constraints over here. One, that you have an AP with consecutive integers. So common difference is 1. And sum of such an AP is 45. So you have to find the greatest number of terms in this particular arithmetic progression. Don't be in a hurry. Don't give answer as 9. Think a little bit further. What is the greatest number of terms of an AP with consecutive integers? Sum of such an AP being 40.
So is my answer correct?
Sumit not correct. Jeevna not correct. 1 second. Pranshu correct. Very good.
Does never mind.
Oh, do I take n as in the formula?
That is the quantity that you need to maximize. So it's a variable or unknown in
Sir,
initially.
is my answer correct?
1 second. Shubhayu not correct. So the answer is not 1 plus 2 plus 3 plus 4 and so on up till 9, and you give the answer 9. 9 is not the largest value. There are other larger values. Think about how to go about attempting this. There might be multiple methods, but the method I'll show will have a trick involved with it, which you can use in other questions in the future. I are not correct. The answer is larger than what you have sent. I have not received your answer.
Can you check if mine's correct?
They are not correct. There will be a longer sequence of integers. Here it is written integers and not positive integers. Okay, so you can have negative integers in your number also. Jocelyn not correct. Try again. Shubhayu not correct. Sumit not correct.
So is the answer even larger?
Even larger. Yeah. Think how can that be possible?
Sir, is answer? My answer correct?
Shubha, you not correct. Sumit, correct.
So Sumit,
Yeah, correct.
Sir, actually, if we are allowing negative integers too, then
Yeah. Don't tell the
theoretically,
answer. Don't tell the answer. No, no. Answer is not infinite. Answer is not infinite. Answer is less than infinite, and there will be an integer answer to it.
no, sir. Actually, my logic being like if you are starting from -100, there'll be a +100 to cancel that out, or as such.
Yeah, but the you can't make that sequence arbitrarily long.
Acha, हाँ, yes, yes.
Okay, should I start solving this? Vaibhav, correct answer. Mihika, not correct. Sujal, yeah, I'll start solving this. So the thing you need to notice over here is that I have written something about the middlemost term over here. Middlemost term sometimes you can find for your sequence if there are odd number of terms. But if there are even number of terms, there is no middlemost term, but you have two terms that are most middlemost. So you have Sn equal to 45 given, and this is n times m. If you want to increase the value of n, you need to decrease the value of m. Does that make sense? Okay. How did the middlemost term multiplied by n become 45? I think this much would be obvious to you. If you have the middlemost term, you have m plus d, m minus d, and so on. If all of these terms are added, this minus d will cancel with this plus d. That's why you will get m times n as your once you add all of these n terms, you'll find that m times n is the sum of your sequence that you'll get. First thing. Second thing, if you have a sequence with even number of integers, you can write it as m minus d by 2, m plus d by 2, where there is no actual middle term, but these two are the middlemost terms who are separated by d. The next term will be m plus 3d by 2, and so on. Here it will be m minus 3d by 2, and so on. I hope everyone is clear about this. Correct. Now m is the average of these two quantities, average of two consecutive integers. All these are integers. Integers. Now, if you have m as the middlemost term, m is the average of two integers, then you want to reduce it. Smallest possible value, smallest positive value of m will be equal to half, because m can be the average of 0 and 1, which is 0 plus 1 upon 2. That way, you have minimized m, that will maximize the value of n. So from here, 45 equal to n times half, which gives n equal to 90. Now, what is this sequence with 90 terms that has some 45? The sequence is minus 44, minus 43, dot, 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 all the way up to minus 1, 0, 1, dot, 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 all the way up to 43, 44, and 45. This is the sequence of 90 terms. All these terms minus 44 will cancel, and you will be left with only this term 45. Okay, so this is a different way of visualizing arithmetic sequences, and you can get an answer very instantly. The other way to go about doing this question is, should I do it? I'll show you how to do it.
So I have a doubt.
Yeah.
Sir, in the method that you showed us right now, you said that the smallest value, positive value of m will be half. But if we are considering all the values to be integers, how can we consider 0? Because 0 is not an integer. Sorry, I messed up.
No problem. No. Sn you can write as n into a 2a plus n minus 1 times d, and d is 1. So you have 2a plus n minus 1.
So won't it be n upon 2?
N upon 2, yeah. So from here you get 2na plus n square minus n equal to 90. And then you have to use some idea to find the largest value of n. To do that, I don't know how readily you will be able to do this. I'll think about another method to go about doing this. In the meantime, you can try doing the next question. This
Sir,
I'll complete.
Is
at a
it
later point.
possible to use the discriminant to solve this question?
Possibly, yeah, you can use discriminant to solve this. Yeah, that can work. N square plus n times 2a minus 1 minus 90. And then n you can write as 2a minus 1, or sorry, minus 2a plus 1 plus minus under root 2a minus 1 the whole square minus plus 360 upon 2. So you try to play around with values of a such that this quantity becomes larger. So you want to have a as negative, and at the same time this should come out as a odd quantity. Of course, it will come out as an odd quantity when a you put as some integer. You want to find the largest value of this under root sign, and then you'll take the positive root, and that way you'll maximize it. But again, this becomes too tedious to solve. You can see now how elegant this other method is.
Yes,
You
sir.
go and search for the middlemost term only, and then you're done. And 90 is the correct answer. Okay, try the next question, which is question number 18. Suppose that an is an AP with a1 plus a2 plus a3 dot 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 all the way up to a100 is equal to 1. A1 plus, not A1, sorry. The next 100 terms, A101 plus A102 plus A103 dot all the way up to A200. This is equal to 200. And this first one is 100, the second one is 200. Find A2 minus A1. Pushkar, answer is not correct. Try again.
Sir Sumit.
Sumit, correct answer. Sumit, what did you do? You took difference of both sequences, or you tried something else? That only.
Sir difference.
Very good. Shreyansh, not correct. Yeah, that might be correct. Just find A2 minus A1. Mihika, not correct. Shreyansh, correct. Good. Vaibhav, correct. Ayan, not correct. I think you have done a tiny mistake. Check your answer again.
What about my answer?
1 second. Jeevana, not correct. Neha, not correct. Okay. Should I start solving this? Or does anyone want more time? The idea is I can give you two ideas.
Sir, just a second.
One,
Sir,
Joycelyn,
what about
correct
my
answer.
answer?
Joycelyn, correct answer.
Sir, is my answer correct?
Yeah, answer is correct. Lakshya, not correct.
Sir, I just wanted to confirm that the sum, like the sum of the 200 terms minus sum of first 100 terms will be equal to 200, right?
Correct, correct, yeah. Jay Verma not correct, Arya not correct. Okay, should I start explaining? Does anyone want more time?
Sir, 1 second.
I'll show you two methods on how to do this question. I'll wait for 1 more minute. Okay, hints are subtract the two sequences, or you can find middlemost term.
We can also add the two sequences now.
Adding will work. I have not gone through that approach, but these two give the answer. So we can explore that also if you like. Pushkal, correct answer. Okay, I'll start with solving this question. Method 1. I'll go with subtract the two sequences. What will happen if I subtract the two sequences? I'll subtract the smaller out of the larger. So I'll write 1 A101 plus A102, so on up till A200 equal to 200, and then A1 plus A2 all the way up to A100 below it. Then I will subtract these two sequences. RHS is simple. It's just 200 minus 100. The first will be A100 and 1 minus A1 plus A102 minus A2 and so on all the way up to A200 minus A100. Now, all of these terms can be written as AN is equal to A plus N minus 1 D, and AM can be written as A plus M minus 1 times D. So if I take a difference of two terms of an AP, I'll find that AN minus AM is simply N minus M times the common difference D. Is this clear to everyone? What I've done over here? Nth term and mth term of AP can be written as follows. If I take their difference, they are simply the difference of the term indices multiplied by common difference. And when you apply this, you will find that all of these terms are simply 100 times the common difference. This implies 100 D plus 100 D plus 100 D is equal to 100, and these are 100 times. Because you start from 1, 2, 3 all the way up to 100, and 101, 102 all the way up to 200. There are total 100 terms over here, correct? So you have 10 to the power 4 D is equal to 100, or D is equal to 1 upon 100. This is the first method. And this is something that you should have thought up on your own. what I'll show you, another way of solving this is, Pushkal, yeah, that might be correct. Another way of solving this is that you consider the middlemost term, m of the first sequence. Method 2. Okay, we have these two sequences. What would be the middlemost index in this term? Think about that. The middlemost index of both these terms will be 50, 51 and 150, 151. Do everyone agree with this? This makes sense. The middlemost terms will be 150 and 151 and 50 and 51. Now I'll introduce a like a new concept which you might not have heard, but it is obvious. This is maths, you can do whatever you want, as long as it makes sense at some point. Okay. I'll introduce something called A50.5 as the middlemost term. This is like a fractional index, but this will help do this question very fast. I'll use the idea that I presented over here as it is. I'll find the middlemost term of this first sequence and I'll find the middlemost term of this second sequence. So A50.5 can be written as 100 and there are 100 terms in this first sequence. So number of terms multiplied by middlemost term is equal to sum of these terms. Then number of terms times middlemost term, A150.5 will equal to 100. Can you sort of make sense of what I've written over here? I've used a fractional index and tried to find the value of this. Now what I can say from here is that A50.5 is equal to 1. A150.5 is equal to 2. When I subtract them, A150.5 minus A50.5 is equal to 1. This is just 100 times the common difference because the separation between these two terms is 100. So 100 times D is equal to 1. D is equal to 1 upon 100. And this implies that A2 minus A1 equal to D equal to 1 by 100. I know this second method might seem complicated. It might seem useless or just it might seem weird to do it once I've explained the first method. But this is also a way you can start looking at arithmetic progressions. They are simply a linear sequence. So properties that you can use for coordinate geometry on a straight line, those same properties you can apply over here also, where this index is simply your x coordinate and your terms become your y coordinates. So that's what I've done. I've taken all these terms. The average of these terms, average y coordinate will be the position of the average x coordinate. Correct? I've used that idea.
Sir, what is the reason behind taking 50.5 and 150.5?
That is the middlemost x coordinate or the middlemost index of 1, 2, 3 all the way up to 100.
Okay.
Okay, that it's always it's to do with the central tendency of the indices, and the corresponding y value times 100 will be equal to the sum. Okay, try the next question.
Sir,
This
can
is a
you
little bit
show
different.
the original question once, please? Okay. Also, I wanted to ask you if we do this using simultaneous equations, would that work? Because I did it that way.
You got the answer?
I used the first sequence as 1 instead of 100, so I did not get 1 upon 100, but I got 1 upon 50 instead of that. So I'm
So
not
you
sure whether it
assume
works.
the first term.
No. I made two equations using the formula for sum.
Okay. Yeah. Using those equations, of course, you can find it. The only variable over here will be common difference and the first term. Correct. So both you can find.
Yes, sir.
And both are linear. So it's like solving two linear equations. I think, yeah,
Yes.
you can do that. That is the most simplest method or the most textbook method. But if you are only depending on textbook methods, you will be able to make your own weird methods. But the point of this is that I can give you those different methods
Yes, sir.
first hand. Okay. 19th question from, sorry, find the product of roots. Of the polynomial. X to the power 5 minus 5x to the power 4 minus 35x cube plus ax square plus bx plus c if the roots are in AP. Now this borrows concepts of Vieta's identities that were discussed in last class, but now the roots are in arithmetic progression, so you can try attempting. You just need to find the product of roots over here.
So what's the meaning of like if the roots are in AP?
They are in arithmetic progression. So wait for 2 minutes, I'll give you a hint on how to proceed with such
Okay,
questions.
sir.
AP means the same logic that we were discussing before. There'll be all terms are in have a common difference. So basically, you have just two variables over here. An AP can be defined with two stuff only: the first term and the common difference, or any term and the common difference.
Sir.
Yeah.
Is it minus 35x cube or minus 25x?
It's minus 35 only, and answer can be found.
Thank you.
Sir, can I assume that there are 5 roots?
Yeah, there are 5 roots. All the roots are in arithmetic progression. So this is a fifth degree equation. So there are 5 roots. So since time is less remaining, I'll just give you a hint. You can assume the roots as a plus d, a plus 2d.
So 1 minute, I got an answer. Is my
This
answer
is
correct?
Sumit, not correct. Try again. Sumit, what have you found? You have found the value of a, or have you found the value of product of the roots?
So that-
Harshit, not
so
correct.
that-
So can you check my answer?
Dian, you have to find the answer as an integer.
Oh, okay.
So answer will be independent of A and D.
Choose. Then my answer.
Just a second. Sumit, you're close but not correct. Done a tiny mistake. Jivna, how is B equal to 2C?
Sir,
It might be correct. I'm not sure if it is correct.
okay.
Uh, so you have to realize one thing, that uh, sum of roots is equal to minus B by A, or minus second coefficient upon first coefficient. So summation alpha is equal to minus of minus 5 upon 1, where summation alpha, this is sum of roots. Okay, if you remember Vieta's identities, the sum of roots is the negative of second coefficient divided by the first coefficient. So from here you will get 5A is equal to 5 and A equal to 1. Based on this, you can proceed and solve the rest.
Sir, what did you like? How did you get that?
That comes from Vieta's identity. This we had discussed in
No,
the
I
previous
got the sum
class.
of roots part, but I was
So sum of roots, but okay. See, A is the middlemost term over here. Correct.
yes.
Sum of these 5 terms will be the middlemost term times 5. So 5A is equal to sum of roots, which is equal to
Okay,
5.
got it, got it.
Okay, I'll leave you guys with one more question after this. Acha, Mihika is asking, how did I know A is middlemost term? This is how I'm defining my AP. Usually this is very convenient to write the unknown terms of an AP from the middle term. Lakshya, very close, but not correct. Not very close, I mean, you are off by a lot.
My
Vaibhav,
answer was
Harshit,
correct. I just solved it
and
mentally.
Sumit, answer will be positive. Whatever you have written, the positive of that will be the correct answer.
Can you check my answer?
Oh yeah,
Diyan,
2 Sir, I did that silly mistake that I did not negative is positive.
one second. Who is asking? Diyan, I'm not received your answer. But you substitute the value of D. Even if you do that, answer won't come.
After like substituting it in the formula I got 1. So then my answer was correct by my formula.
One is not correct.
Okay.
Okay. I think I should start solving this question. This requires you to juggle around a little bit with Vieta's identities, and this is not that much of a arithmetic progression question. The only logic of AP that you have to use is that you write your sequence from the middlemost term. Okay. Then after that, it's full algebra jugglery. Summation alpha beta, or this is equal to minus 35 upon 1, which is minus 35. This is sum of product of roots taken 2 at a time. Okay, so I'll write a particular formula. Try to reason why that is correct. Summation alpha, the whole square, is equal to sum of alpha square plus 2 summation alpha beta. Do you agree that this is correct? I'll give you smaller examples like a plus b plus c, the whole square, is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Correct? This is the very well-known identity that you know. This can be also generalized to arbitrary number of terms. That's why when I write summation alpha, I mean as many terms as I want. If I square them, it will be equivalent to adding up the squares of those numbers plus the twice the numbers taken two at a time. This is all a consequence of distributive property. Okay, so if I use this, I already know what summation alpha is. I already know what summation alpha beta is. If I can figure out summation alpha square, this question will get solved. Okay, so summation alpha, I'll just keep this a little bit aside. Okay, summation alpha equal to 5. Summation alpha beta equal to minus 35. So this implies summation alpha square equal to 25 minus 2 times 70. Sorry, 2 times 35. Minus of minus 2 times 35, that is equal to 75 plus 25, 95. Okay, so sum of squares of the individual terms will be minus 95, and this is equal to a minus 2d the whole square plus a minus d the whole square plus a square plus a plus d the whole square plus a plus 2d the whole square. Now just see what will happen over here. A square minus 4d plus 4d square, 4ad, plus a square minus 2ad plus d square plus a square plus a square plus 2ad plus d square plus a square plus 4ad plus 4d square. Has everyone understood this? These are separately the squares of all these terms. Now, if I do some cancellations, it turns out that this is equal to 5a square plus 10d square. We already know what a is. A was the middlemost term that we had calculated as 1. Correct. So we have, this implies 95 is equal to 5 plus 10d square. And from here we have d square equal to 9. I can cancel 5 on both sides and then divide by 10 to get 9. And we have d equal to plus minus 3. It doesn't matter. Both are equivalent and both are correct. The positive and negative values of d will actually come. And then you get 1, 4, 7 and minus 2, minus 5. Because this is the middlemost term, a plus d, a plus 2d, a minus d, a minus 2d. And when you multiply all of these, you will get 280. Okay, this was the entire proof for this question.
Sir, my answer was a bit different.
What did you do?
Sir, I found C.
You found
And then
C.
the
Ha,
other.
finding C is also the same thing. C is also product of roots. So good.
Means I did not find by this method. I use C, sir.
But how did you directly get C? Did you put x equal
Not
to 0 or but?
sir, not 0, sir, not 0. By sir,
What did you
by
do?
get so from the equations only we can write an equation for C now. And we will get 1 minus C equal to negative of 1 minus alpha.
Okay, whatever. You can message me your solution. I'll go over it if it is correct or not. I'm done with the contents of today's class. We'll meet 2 weeks later.
Sir,
See
will
you
you
guys.
put adding this to the document as well?
It is in the document itself. So if
I-
you have the link from previous classes, it's the same link that I've shared today also.
I cannot see it. That's why I was asking you.
No, it will get updated after the class. Once I update it, it will get updated.
Yeah, actually, where we will get the recording of these classes?
Recording, I am not sure. You need to contact
Yeah.
Tulips about it.
And are you talking about the notes?
Yeah, notes I've shared it in the chat.
Sir, it is
Chat?
available on YouTube.
Some videos are available in the on YouTube, some are not available. I'll be ending the class early because I have somewhere else to go also. See you guys later, 2 weeks later.
Classes are up in 1 week, sir.
AMC 10, 12 seminar. Bye.
Yes, sir. And now they are not live, some classes, but they are updated within 1 week.
Chalo, ठीक है then. You can get the video recordings on YouTube also, as Sumit has mentioned. Bye, sir. Bye.